As we move along in our exploration of sequences and patterns in general, let's take a look at another pattern and see if there's another way, just like we were looking at before with proportionality, we're looking at different representations. So if we can see if there's another way to represent this particular pattern. And then we can bring all of that together into representing patterns with multiple representations like drawings, graphs, tables, sentences, and algebraic expressions. And there are a couple of ways that we can even do that. So let's take a look. So we have some entries. So position 1, we have 5, the entry is 5. Position 2, we have 8. So in other words, we have this sequence, 5, 8, 11, 14, 17, right? And then we're calling this position spot 1. And this is spot 2, and this is spot 3, and this is spot 4, and this is spot 5. Okay. So what do we notice? What do you see and what do you notice? A lot of the kids will start looking at these numbers and they'll say, hey, I add 3 each time. Right? So it's as if I'm making that arm longer by 1, right? And I have 3 arms. So if I wanted to get 6, position 6, it would be 20. Well, but how would I go from, if I wanted to go from 17 to 14 to 11 to 8 to 5, wouldn't I be subtracting 3 from each time? From each step. So the question A says, well, if there were a position 0, what would that position be? Right? Well, what plus 3 is 5, right? 2 plus 3 is 5. So position 0 would be 2. Now, let's try to then work on filling in this. Because just like in before, when we just have the numbers here, it's not quite as evident what the structure of the pattern is. It's we need to get into it. We need to dig into it a little bit better to actually see the structure. So let's see if we can do that. So to find the entry in position 1, start at 2. Oops. Right? We're going to start at 2. Okay, we're going to start here and we're going to add 3. And add 3 one time. Now to find the entry in position 2, we're going to start at 2. And how many times do we need to add 3? Well, this is 1 time, 2 times. So we need to add 3 2 times. Now, if we're looking at the entry of position 3, we could, if we start at 2, we need to add 3 3 times, and so on. So 2 to position 4, we need to start at 2 and add 3 4 times. Position 5, we need to add 3 5 times. Now position X, we're still going to be adding 3, but we don't know how many times, X times. So it'll be X times. So that's really interesting. So let's write the expression for each one of these. So in other words, we're going to dig into how did we get that 8? How did we get that 11? So for position 1, we started with 2 and we added 3 one time. Right? And we can even say 1 times 3. For position 2, we started at 2 and we added 3 2 times. Position 3, we added 3 3 times. Position 4, we added 3 4 times. And position 5, we added 3 5 times. Now let's take a look at our parameters and our variables. So it looks like 2 doesn't change, and it looks like 3 doesn't change. What does seem to change is how many times we're going to be adding 3. So if we have x and y, so if this is our x, if x positions, then our y would be 2 plus x times 3. Our x is our position, and these are our parameters. And we can rewrite that as 2 plus 3x. Now, it's hard to get that from the 2, 8, 11, 14, but if we start breaking these up into this kind of format, 2 plus 1, 2 plus 3, 2 plus 2 times 3, 2 plus 3 times 3, 2 plus 4 times 3, etc., what we're getting at is we're getting at the structure of that number and of that sequence. And that's extremely helpful to be able to come up with the final expression. So let's see what that looks like now on the graph. So our initial position of 0 was a 2. So 0, 2, and if we graph this, then 1 would go to 5, and 2 would be at 8, etc. And etc., etc. And we can actually draw a line through these values. And what do we notice about the line? What do we notice about the position? Do you notice that it's a straight line, similar to proportional? But what's the difference with proportional lines? This is the difference. Now, in proportional, if you remember, proportional lines started at 0, 0, and then had a constant change. But with this is a linear expression, where the constant change is still there, but we're starting at a different point. There's a different start. So what I would like you to do is take a look at F on your own and see if you can explain how the points relate to the graph and how this is similar and different from proportionality. And then you can do the same for question 2.